Hello. Good afternoon, everyone. This is Shesh Narayan Agrawal, and today we are going to talk about the technical overview of high-speed data warehousing appliance, which is powered by IBM Pure Data System for Analytics. IBM Pure Data System for Analytics is also known as Netezza. You might have probably heard this name, Netezza. And basically, I come from the development organization of Netezza, whereas I work on the next generation appliance development for Netezza. We'll start the session. So as you could see, the slide number 2, which talks about the various verticals IBM has as far as Pure Data Systems is concerned. So we have essentially three Pure Data Systems verticals. One talk about transactions, the second one is about analytics, and third one is about operation analytics. So in today's session, we are mainly going to focus on Pure Data System for Analytics, which is the center, right, powered by Netezza. Now, the quick difference among these three different families of Pure Data is basically one talks more about the transactional, right, OLTP kind of an application. The Pure Data for Analytics talks more in terms of optimizations and analytics. And the third one, which is System for Operational Analytics, talks mainly about real, analysis at the real time. For example, fraud detection, right? So these are the various categories of Pure Data System families. Now, Pure Data for Analytics, right? I mean, this is the big picture for big data platform. And as you can see, that data warehousing is one of the components in the big data family, right? I mean, entire big data platform. So it's very important component as far as the analytics is concerned in the big data environment, right? And as you know that IBM has, various products and the tools available to get this big picture of the big data platform, and Netezza being one of them, right? For data warehousing solution. Moving on to the next slide. Particularly about Pure Data System for Analytics. Earlier this year, we launched the N2001 family, the code name called Striper, right? Before that, it was N1001 family, right? Basically, historically, Netezza is known for its simplicity, right? And some of the capabilities, which continues to provide in the current release, which is N2001, is like, faster time to value on the market today, the optimized big data analytics. Netezza comes with a lot of inbuilt analytics capabilities. In the following slides, we'll talk about that. And the most powerful component and the value add for Netezza is basically simple administration, right? And there are a lot of things to cover, like, for example, it does not really have indexes, right? You don't really have to worry about your storage space managing and all that stuff, right? So it comes with all those administration, and there is another slide where it lists some of the otherwise other databases, other appliances if you go for would require to handle, but in this case you really don't have to worry about all those nuts and bolts. And of course, performance, right? Because it comes with the both hardware, software, and server together. So it is basically optimized for the best possible performance. Moving on to the next slide. Now this slide, basically slide number 5, is the comparison what N1001 has to offer and what we have in N2001, right? It has better performance, of course, with every new releases. IBM keeps, and for that matter, any product keeps, getting better and better. And in this case, we got 3x faster performance as compared to the previous release. It has more scan rate, 120 GB per second scan rate, because in data warehousing solution, one of the important, factor is that how fast I could scan the data, right? And because it's mainly about the analytics you're going to perform, right? Not necessarily that you will be making a lot of updates every now and then, but the very important factor is that once my huge amount of data is loaded, right, that how fast I could read, right, and perform analytics on that. So From that factor, 120 GB per second is basically the scan rate what you get. And we have added more hard disks to increase the capacity, right, which is kind of 50% greater. And here there are compression factor which also gets in, right, that typically we get 4x compression on your data. And also some of the resiliency factor has been incorporated, whereas we have got little more spare drives in case of any disk failures. That's one of the common components which is seen in such appliances, right? Whereas it basically some of the points of the failure on the hardware side. Moving on to slide number 6. So when we talk about how the high speed data warehousing, right, the appliance and solution, right? So actually how did we achieve it, right? So this is the slide where it says that from in the current release we have 2.5 drives at 130 MB per second is basically throughput rate for each drive is basically mapped to the one core, right? And there are two things in here. At the center we have FPGA called Field Programmable Gate Array, and which is what we call is basically the purpose-built accelerator, right? And what we call is a secret sauce for Netezza. And there is another slide where we'll talk about that. What does it do, right? And so 100 MB, 1000 MB per second is the processing speed you get once the data is read from the disk, and then basically we pass it on to the CPU, right, for further processing. And there is another slide. We'll talk more about that. But in short, in each blade, right, we'll have a combination of disks and then FPGA core and the CPU core. Slide number 7. This basically talks about how the mapping of cores with disks have been done. As you could see that, in the S-Blade side, there are 8 CPU cores and 8 FPGA cores, and it maps to the 8 disks. So basically it is 1-to-1 mapping, right? For one disk, we have one FPGA and one CPU, right? So in N1001, we have total 14 blades per full rack, right? And it's available on the different rack configurations, and we'll talk about that. But in one full rack, you will get 14 blades. Each S blade has basically 8 CPU and 8 FPGA engines, and size to handle 8 disk, 960 MB per second rate. So that makes it basically 92 active data slices, which delivers approximately 11 GB per second raw disk throughput to the core, to the S blade, right? And the next slide, which talks about N2001. The significant difference here you see is that in the per S blade, the number of cores have been doubled. However, the number of blade itself has become half. So eventually, the number of cores in a one full rack system between N1001 and N2001 remain same, right? The number of cores, but the number of S blade have reduced, and that is that each S blade in N2001 now hosts, more number of cores than what we had in N1001. So here, as you could see, one of the interesting points is that in the previous slide number 6, I mentioned that 2.5 disk is mapped to each core. So here, as you could see, that 40 disks are there for 16 cores, right? So which approximately comes, which comes to 2.5 disks per core, and that is done for 2 of the blades. Rest of the blade has basically 1-to-2 mapping, right? 2 disks for each, core. So the reason it has been done is that the core, power is more than what data it can, get from the disks. So to address that problem, it was felt that if we can ingest data, if we can read, if disks, what disk enclosures can give the more data throughput to the CPU is capable enough to process the data, right? So that factor has been incorporated in N2001, and as a result, we get 3x, 3 times more disk throughput, right? And there is another slide where it clearly mentions the difference, and we'll see on that. And as you could see that we have 240 active data slices in case of N2001, which is like double the capacity wise. Now this slide talks about the various components available, right, at the very high level. So it has 12 disk enclosures, which are basically results to 288 600 GB SAS2 drives. So 250 of them are user data, 14 are consumed by S-blades, so 2 per blade, and then there are 34 spares, right? And in one of the slides I talked about that the number of spares in N1001 actually was four disks, now which has been increased to 34 in N2001. So this is to kind of meet the eventualities in case of any disk failures, right? And it has 2 hosts. Even N1001 has 2 hosts, which is active passive. So at one point of time, all the applications would be talking to one host, which is the 2 6-core Intel processor is there, and which has 2.1 almost 2.1 TB of storage, and it runs basically on HCL 64-bit. Now talking about S-blades, as we saw that it has 16 cores for CPU and 16 cores for FPGA, which is Xilinx Virtex processor, right? And each of the S-blade has basically 128 GB of RAM, right? And it also runs the Linux 64-bit. Now, as you could see, the user data capacity in the full data rack will come as 192 TB, right? And data scan speed is 450 TB per hour, right? And these are all assumed as a 4x compression. Now, one of the important factors in the data warehousing solution is that how fast you could provide and load the data in your data warehousing environment. So in case of N1001, it was approximately 2 TB per hour, which has been increased to 5+ TB, right, per hour speed, load speed. And still continues to be power requirement under 10 kilowatt, which is one of the norms for data centers. So it still comes within pretty much that limit, right? 7.5 kilovolt is the power requirement for one rack, right? So this is the comparison you could see in terms of the hardwares of the N1001 and N1002 offers. So HS22 is a blade type for N1001, and HX5 is a blade type for 2001. As you could see, the raw capacity for older version is 96 TB, and the newer is 172.8, right? And it has the number of disks has quite significant in case of the N2001, right? And the rack configuration, which is very important part, is that in N1001 you will have quarter to the 10 racks, whereas in case of the N1001 it is like half racks to 4 racks today, and 6 and 8 racks going to follow soon. If you have any questions, please, either you could post it on the chat, or maybe you could hold towards the end. We'll take all the queries towards the end. So, as I said, the user data capacity is 128 TB, and the maximum capacity for entire system is going to be 1.2 petabytes for N1001 and 768 TB for N2001. And the reason is that the reason difference in the new and the older version is basically that we have more number of racks to offer in older release versus the new release, which anyway I said that will be releasing shortly. And that's the minimum capacity each of the appliance will offer. Now slide number 12 basically talks about the workload as compared to the new and the old one. And you could see the single rack system basically offers 13 query per minute in the mixed load environment, whereas in case of the latest release, you would get 45 queries per minute, right? And not only that, you will get 45 queries per minute in the mixed load environment, but the number of users it can handle at given point of time has been doubled as well. So let's say in case of older release like 24 users can run 13 query per minute, and in case of the latest, it will be 48 users, right, with the same rack configuration. So as I was talking about that Netezza, one of the greatest, capabilities of Netezza is basically simplicity, right? And it does offer the GUI portal, what we call is, NG portal, right? And NG admin, right? Which comes basically, whereas you could monitor your disk usage, how many users there, what is that load currently, are there any failure on the disk, are there any disks which are in the regeneration, how my plates are performing. Entire health check and the, monitor of your queries and everything could be done through NG admin, right? Now, talking about the simplicity, you do not really have, there is no DB space concept. There is no table space concept in case of Netezza. There is no redo physical logical log which you have to worry about. There is no page or block level sizing you have to worry about, right? There is nothing called extent. There is no temp space. There is no indices. There is no red level decisions for DB space which you have to make. There is no logical volume of, file creation you have to do. There is, you don't really have to worry about your software upgrade and all that stuff, because it comes as a, appliance which is basically hardware, software, and your server together, right? The only thing you have to do is basically create your table with a proper distribute on column, whereas you expect your basically query to be doing, the predicate on, right? And basically you just load your data. There is no extent, there is no table space, there is no DB space which you have to kind of specify as a part of your DDL, right? You simply just create a table, whatever you need, whatever data types you need, right? And simply load your data, right? You do not really have to worry about creating indexes and all. Indexes and other such things for performance reason has been, kind of handled internally, which is not really known to the users, and we'll touch base on that as well. So this is the web admin and the NG admin portal I was talking about, whereas you could go and monitor system resources, perform system administration in terms of it's very little actually system administration you might want to do, right? Pretty much everything is optimized, right? Like for example, if you want to do when you delete the records, right, you might see that whether it has been groomed or not. So such things basically could be seen from in here, and also how your system is performing as far as workload is concerned. You might have allocated certain users certain amount of resources. Are they really being followed or not? Or do you see any, somewhere some bottlenecks as far as workload management is concerned? And your storage space, and basically it can help you in a better planning, right? This portal, it will give you the health of the entire system, that how much space is, what is consumed, what is available, right? And how over the period of time your each SBlade and cores are basically performing. Moving on to slide number 15. N2001 by default comes with the Netezza platform software called, that version 7.x, right? The previous version was 6.x. So this is the software part of it, which is basically, which comes with the appliance, right? The entire hardware software package. So some of the improvements which has been done is basically, for tactical kind of queries, it has been improved to get the better throughput, direct data processing for improved concurrency. So things have been changed in terms of the distributions, and page level zone maps, eliminating unnecessary disk scan, which is very important, right? As I mentioned at the beginning, towards the beginning, that one of the very important factors in the data routing solution is that how fast I could actually scan my data from the disk, right? And this zone map enhancement has given a really lot of boost in terms of that, how do we really want to decide that how much data will be reading from the disk. And there is another slide where we'll talk about what zone map is and basically how it has been improved. And so also in terms of efficiency, right? It has come with the performance portal also now in 7.x, and a lot of enhancement have been done in the optimizer side, memory management, and how do we want to communicate internally with various components, because it's pretty much hardware as well from inside, right? And then faster, better, and completely transparent to the users, right? So this is where we talk about direct data processing. So what it means is that you want to distribute your data in such a way that when you query on that particular column, right, then it should give you the fastest possible, performance. So in this case, what we're saying is that this particular table called transaction history is distributed on customer ID. And as you would see in slide number 17, if somebody performs, somebody issues a query like select this table from this, select all the columns from this table where my cust ID in 1 or 2, right? So in this case, as you see that the disk, right, basically has already been distributed on a particular customer ID. So all customer ID 1 is in one data slice. All customer ID 2 is another data slice, right, and so on. So when I run such query, it knows, right, where to go for data, right, where to look for my data. Now, and it's more importantly is that it works in the reverse way. Actually, it tells you that where your data is not there, so that you do not really go and scan those data slices, right? So which is very, very important. It's very important to know where my data is not there, right? So that I do not really spend unnecessary, scanning and the processing capability on those data slices. So that's what we are talking about, direct data processing. Now, talking about the zone maps, earlier we used to have 3 MB page size. So what is zone map, right? So zone map basically keeps information about your column, all the numeric columns, minimum and maximum value, which is kind of one of the internal tables, which you do not have to worry about. You do not have to maintain or manage. It's just that, it internally it manages, and it keeps for each column in that particular page maximum and minimum value. And it knows where this data is in my data slice. So which is more of a kind of index, but inverse index. So in previous releases, we used to have 3 MB of page sizes. So if you see this diagram on your left, right, there is this October month, which is kind of color coded as blue, which are there in 4 different chunks, right, except one. Total there are 5 chunks. So if I have to really get a query where column equal to October, then I have to get my 4 multiplied 3, right, which is 12 MB of page size to be looked for. Whereas, to figure out where my data is. Now, in the latest release, the page size has been reduced to 128 kilobytes. So in this case, if you see on your right that I have 8 pages of 120 KB each, whereas my October data is located. So I'm going to scan just 1 MB of my data, right, as compared to 12 MB, right, which I have scanned otherwise. So this basically helped you to faster, disk scan and to locate where my data is. Now, so far we talked about more from the data perspective, right? How do I manage my data, and rather there is nothing much you could do on Netezza, right? It's just that you create a table, dump it, on the storage, which is it by default it provides, and basically you are just ready to file your queries, right? You do not have to do any tuning or anything as long as your distribute on column is pretty much specified there, right? So now let's talk about the analytics, right? What is that analytics Netezza has to offer today? So again, if you look at the slide number 21, it's a purpose-built appliance, right? Which is basically which gives you basically high performance analytics, right? And it has essentially, you could see it has 3 components, right? SMT hosts, whereas we talked about active and passive, and this is where it runs the all your query plans and optimizer is being decided in one of the hosts, right? I mean, it will always be active host, but in case if active fails, passive will take over and make sure that they are running all your query plans and optimization and some of the administration you want to do from there. Now, as far as the disk enclosure is concerned and snippet blades, right? That is where you possibly would have no idea, right? Or you will have access to all these things. You will have no access to all this, whereas you can directly go and talk to them. Absolutely not, right? You focus mainly, and all your applications basically talks to hosts, Rest of them are more of an abstract for rest of the world, but it's pretty much defined in such a way that host is capable enough to talk to blades, and then blades basically goes and talks to disks, right? And one of the important things here to note is that pretty much everywhere in NetDesire appliance is kind of redundant. So what it means is that in terms of high availability, for example, that we have two hosts. So if active fails, passive will take over, right? Until active comes back, and of course passive becomes active, and then active becomes passive, right? So that's one level of high availability which has been inbuilt. Now, in case of disks, what happens is that if, let's say, I have my some part of data in disk 1, for some reason it goes bad, right? So how do I get that data? Now, each disk has essentially 3 parts. One is called basically your original data, user data, and then other portion is called a mirror of the data from the other disks, right? So for example, if you have disk 1 and disk 2, so disk 1 will have its own original data, and the mirror part of disk 1 will have original data of disk 2, and so on for disk 2. So disk 2 will have original data of its own and the mirror data of disk 1, right? And there is another portion which is basically reserved for the swap space, right? When we run a query and there is a large amount of data to be scanned and kind of intermediately stored, so that's where the swap space is being used, right? Right, and right, I mean, as we know, that Snippet Blade basically has both the FPGA as well as the CPU component, the core processing. Now, moving on to slide number 22, this is the so NetDesire is basically the AMP architecture, right? On the Blade side, we have MPP architecture, and then on the host side, we have SMP architecture, right? So which makes it basically AMPP architecture, right? Asymmetric multi processing. So as you could see that all your applications basically talks to the host, and then host talks to each of the blades, right? And in between there is a network fabric, and each of the S blades have basically respective disk enclosures. Now, actually, this is another slide 23, right? Actually, it's an animated slide, so you could see something is overwritten. But I'll just explain you, for some reason the animation is not coming in here. But the core idea here is that in case of the N1001, we used to have one disk. We used to, and the throughput was 120 MB per second, which it used to provide. With that rate, it used to provide data to FPGA, right? And then FPGA used to process and then provide to CPU core. In case of N2001, this one disk has been changed to 2.5, which gives us now 1300 MB per second, right? Because each drive gives me 325 MB per second, which basically yields to 1300 MB per second. With 1300 MB per second, the FPGA core receives the data, and as you could see in this slide, the FPGA does actually 4 essential things. The data what it receives from disk is always compressed. So first thing FPGA would do is that it will decompress your data. After that, it will project the select list, right? So for example, select, column 1, column 2. So all this filtered column list will come in the next stage, right? So it will filter the data. So it decompresses, it knows that, it looks at the query, it says that I just need to, pass on the 2 columns out of 10 columns, so it will just reduce right in here. After that, it does the where clause, further filtering. If there is any where clause, it will go and further reduce the number of rows it has to pass on to CPU. And there is, 2 more important things here is a restrict visibility, right? So what happens is that there might be a query which are kind of, inserting or loading large number of records into the system when this select query is being run. So to maintain this visibility, there is this is where this FPGA core comes very handy, is that it maintains visibility in such a way that even though data will come all the way to this state, but there is a special handling saying that if this data is not committed yet, please do not move this data to the next step, right? Which is basically handing over to CPU core for the aggregation and group by. So it gives you the only data, right, which basically satisfy my criteria. And that is where we're talking about, as such, not really you have to worry too much about logging and all that stuff, right? It basically goes and maintains the visibility and it stores the data in the proper data slices until and unless it is committed, its visibility will be restricted. And, so this data goes to the CPU core, whereas it gets the group by and other aggregations capabilities. And then basically it passes on this data to the host, and then host goes and talks to the applications. So that's where data streaming. That's another slide number 24, where we're talking about kind of that how streaming is happening. But since animation is not there, right? You can kind of visualize that I got the more data in the decompress section and the reduced by the select projection list, and then further it based on the where class, and then basically it passes on to CPU core for group by aggregation. And that's the query at the bottom, whereas we could visualize that what's going on with each, the disk and the core FPGA core and the CPU core. Now, slide number 24 basically talks about the various moving parts of the entire, AMPP architecture in action. So, as you could see, right, some of the things are not listing, as you see that, Solaris X, HP, Linux, Windows, and then there's a box which is not listed, but not coming the data, but okay, so probably it will not come. So this box basically says that the kind of connectivity tools, APIs available to talk to Netezza, which are three, ODBC, JDBC, and OLEDB. Now, Netezza also offers what we call is a high-speed loader and unloader, right, which is based on its native external table capabilities, right? Whereas ETL servers, DBA CLI, and all other tools basically can use this high-speed loader, right? Now, as you could see on the host, essentially two things are there, right? All the SQL related things, and the execution engine, what we call is a DBOS, right? Database operating system, kind of a logical, kind of partition, as you can see, right? So SMP host basically takes your query, compiles it, creates the plan, optimizes it, and basically hands over to execution engine. And execution engine basically is responsible to make sure that it is executing your query across all the S-blades, right? And there is another slide where we talk about what we call is a snippet, and we'll talk about that. Now, just to summarize that what's new in the latest release is basically we have almost double the as compared to the old one, the storage capacity. We have a 3x scan rate, and then improved resiliency and fault tolerance as far as the some of the regeneration of the drives are concerned, or in case of any disk goes bad. So on all that we have a more number of spare disks to handle that. Now, how do we really leverage now the analytics, right? We talked about kind of, how some of these. Now let's see that. What is that smart analytics should be your goal, right? Again, these are some of the studies done by IBM, various groups of IBM. And it says that certainly you need analytics to be in part of competitive world, to make your business grow, to make the right decision at the right time, right? And that, the kind of data which you have is basically, how useful it is, right? So that's essentially what it talks about, and it gives you some glimpse of that, what market is benefiting when they go for analytics. Now, and this is another thing is about smarter analytics. Now, I have various forms of data, various data sources where my data is coming from. It could be social data, it could be web data, it could be transactional data, right? And I would want to perform certain analytics on that. It could be operational, it could be predictive, right? It could be spatial, anything like that, right? And then basically I get my result. So this is where Netezza is going to help you, right? The pure data system for analytics is going to help you. Now, if you see the slide number 30, right, how do I achieve my smarter analytics goal, right? So, for example, I have a challenge, difficult adding new data or analytics capabilities, right? So the solution, what you need is increased agility, right? And similarly, if you are saying the growing cost of IT, then you need to be more efficient. Your entire ecosystem needs to be more efficient, right? And of course, the resource administration complexity, right, which is one of the costliest things as per the various studies, right? The resource what you involve to handle your systems, to maintain your system, to manage your system, right? So simplicity certainly plays a big role to kind of check on those costs. Now, how do we achieve this ecosystem of the smarter analytics? So Netezza provides what we call is in-database analytics, right? Whereas a lot of analytics capabilities come inbuilt, right? The biggest advantage, and again, so let's talk about some of the software development capabilities first, right? It comes by default with a lot of your development languages which you might want to write. Some of your applications are some of the what we call is UDF and UDAs, right? UDFs and UDTFs, it's pretty much common across other databases as well. So about UDA and UDAP is what we're saying is that some of these analytics kind of capabilities provided inside Netezza, whereas you could write your own analytics APIs using either Lua, Perl, Fortran, and all other languages, MapReduce, right? Java, Python, anything like that, right? You could write your own UD analytics, functions, register those functions with the Netezza server, Netezza, an NPS, and you're ready to go. You just need to fire the query, SQL query, which basically uses your function, and it will perform all those analytics, the functions you might have written inside the engine itself, right? You do not really have to move your data out of the appliance, right? Which otherwise you would have to do to perform analytics on that, right? So there are various tools which are pretty much integrated with the Netezza, right? ES4i, Eclipse, Visual Tools, right? And as you could see that other in-database analytics like, SAS, Zementis, Fuzzylogics, right? IBM SPSS, all these things are integrated with the Netezza. Now, here in the slide number 32, we can see that how this in-database analytics is driving productivity, right? Again, this is some of the studies done and some of the analysis done that if I do not have those in-database analytics capabilities, then what was my, effort and the entire administration, data cleansing, data exploration, and model maintenance and everything. And once I have a pure data in-database analytics, then how it reduces, right? And some of the advantages is that no data movement, right? So entire my data is in my appliance, and I basically work on those data without moving it out. I perform certain analytics on those data right there without moving it, right? And here we're talking about not just the sampling. When you provide the reports and analysis, you are not just doing sampling, but you are actually performing on your accurate, right? Which is on your entire data, right? And of course, it's MDB scoring, which is faster, being no data movement, easy to govern, lower infrastructure cost, and improved analytics productivity, because again, you're doing everything in place. Now, this is where again, this is more of an animated slide, but it's not appearing here. So what it's saying is that my application issues the SQL queries. It is basically handled at the beginning with the host, and the host basically creates what we call a snippet, and this snippet is being run in each SBlade. Result is written back to the host. All the results aggregate is done and send it back to the application, right? So this is about it. Now, as you see this slide, right? Whereas instead of SQL, now we are talking about extended SQL. This extended SQL is nothing but your, analytics kind of a UDAs you might have written. And as I said, that it comes with a lot of pre-built such analytics functions. Netezza provides, and there is a list in the next slide. We'll look at that. It comes with a lot of inbuilt analytics queries, right? I mean, the functions. You just only need to make, your query to call and to execute all those functions which are provided inbuilt. So here, extended SQL is being issued from your applications. It goes to host. Again, it creates a snippet of your SQL query. It goes and runs in each SBlades, those snippets, gets the result back, And as you could see here, accelerated result, right? In the previous slide, it was like just the result. So accelerated result is more in terms of that analytics have been performed on your query, right? And you are getting the faster result as compared to if you would have moved your data out and then performed analytics on it, right? So that's what it means by accelerated result. Now, slide number 36 is what kind of it is talking about in terms of the, some of the pre-built in database analytics is provided with Netezza, right? So as you can see, a lot of predictive functions are provided, lot of data mining, geospatial, mathematical, statistics, time series, and transformations, right? So all these things could be used, right? At absolutely, from the SQL queries directly, right? You do not have to use any other tool or mechanism to basically execute these queries. It's already registered in Netezza database engine, right? Whereas it knows the syntax, semantics, and what it has to do with that function. This slide number 36 is more, in past I kept asking this question myself, right? Why do I need analytics, right? There is a lot of buzz about analytics, and why do we really talk about analytics, right? So this slide basically gives you a glimpse of that. What is that, in the industry, the analysis has been done and what they found, right? So it says that it returns, 10.66 unit of, money, when you spend one unit, right? So I'm sure this is more from the reading perspective that, what it talks about, but essentially it says that analytics is very important for your organizations to be competitive, right? And do the right thing at the right time, and know your data, right? What your data is all about and how you really leverage on your data, which you would have already kind of, gathered over a period of time, right? So with that, we kind of finish the presentation. Now I'll open the floor for the questions. So if you have questions, please ask now.
All participants are now in interactive talk mode.
Yeah, any questions, please?
Also, this is Bharat here. While there are questions, also just to let know, we have online polling being conducted. Please respond to the poll queries on your screen.
So if you don't have any query, probably we'll close the session, Bharat.
Yeah, that's right. So thanks, Shesh, for the very informative presentation. So I'll also like to inform the audience to please go ahead and register with the Big Data community, India community in DeveloperWorks. And we will use this community for further updates and further for further collaborative information. And yeah, thanks again for all of you to join, and we will conclude this session. Thanks all.
Thank you everyone. Thanks. Bye-bye.